Good morning, guys, one more time, and let us continue with the next point. Now, when you talk about the functions, we already have seen the basic function, how we can start writing a function, and we already have seen a couple of different ways to create functions, a couple of different ways to start sending the data or start sending the parameters, and now we want to continue further. Okay, so let's see where we can reach today. There are many things we have to discuss. Let us see whether it is possible for us to finish all of them. So this is not for you. Where are we? Python, Python, Python. Here it is. Okay. So yesterday we started with that function. Today we want to further continue it. Okay. So let us see what you mean by that function today. Now, when you create a function, before I start with anything, let me come back here in my code and let us create a page as usual, page1.python. So now those people who will be able to see the blank page, now you're able to see the page1.py, or simply refresh it. So you'll be able to see that. Now I'm going to create a very simple function. The function with the name function1, you probably can recall, to create a function, we start using the def keyword, then we put the function name, and then if required, we can put the parameters as well. So this is how we start generally writing the function. Now, right inside this, if you can recall again, we do not start writing the code. We start using something called as a docstring. So probably I can say this is a simple or maybe a test function, or simply a function one, as simple as that. Now, what do you want to do here? I don't want to do anything. I simply want to say this is a simple function, and I want to put a inside function one statement here. So inside function one, there's nothing inside it. It's very, very simple function. This function is returning nothing, means by default it returns none. So this is something which we already have discussed yesterday. So now I'm going to make a call to that function, because function on its own will never get called. You have to literally call that function by using that function name. So let me again continue. If say run this function, run this code, and probably I can see that my function is getting called. Okay. So probably this is something which we have discussed yesterday. This function is not accepting any parameter. Now let me comment this and create quickly one more function which is having at least one parameter. Actually, I'm going to add two parameters there. So probably I want to say this is my function 2, and right inside this function 2, I want to add two parameters, p1 and p2. Now again, don't forget to add the docstring here. For now, you can skip it, but again, make a habit that whenever you are writing a function, always start creating the docstring. It will help you to understand why you have created that function and what are the parameter types you are expecting from your caller, and also you'll be able to see what exactly that function returns. So right now, I just want to print I'm inside that function 1 or function 2 precisely. I also want to print the details about that p1 and p2 parameters. So p1, want to print the type of it, type of p1, and want to do the same thing for p2. So this is p2 is equals to p2, and the type is equals to p2. As simple as that. Now, when you talk about the function 2, here we can pass any two parameters or any two values. Let's say 10 and 20, for example. The moment I pass 10 and 20, I hope you can see both of them are integers. So I see the data type of p1 and p2 changed to integer. So that's pretty simple to understand. Now, important point here is when you are calling this function, you can pass directly 10 and 20 like this, or you can pass say 10 and 20 with the parameter names. So maybe I can say p1 10 and p2 20, as simple as that. So even if I do this, probably I'll get the same answer. And of course, you can also say P2 is equals to 20 and P1 is equals to 10. That is also fine. So probably you can say something like this. Again, the answer will remain same. One more way, maybe I can say this is 10 and P2 is equals to 20. That is also fine. So probably when I say run, this is also, the combination can also be working very fine. You can see that it's working without having any problem. And probably we are getting the values for P1 and P2. So this is something that we have discussed yesterday. This is something you already have written the program for. So probably, yeah, the different variations are working fine for the function. Okay. Yes, maybe Adesh are saying like why it is required to have two lines. It's not from Python, it's from PyCharm. So PyCharm says like whenever you are defining a function, skip 2 lines and then make a call, or maybe start writing the code. So it's not from Pythons, it's from PyCharms. So those who are using PyCharm, they follow this rule. So whenever you are calling a function, you put 2 lines, or you skip 2 lines and then you continue doing this one. Okay, so Adesh, this is not from Python, this is from PyCharm. Tomorrow, if you change your ID, you might use only one line. It's okay. So probably, yeah, in this case, if you're not using or if you're not skipping 2 lines, it will not give you a warning. It will give you a suggestion. This is not a warning. This is a suggestion. It says it's better you can just go back and put 2 lines. So this is not a warning. This is a kind of a suggestion. And this is not from Python. This is from PyCharm. So even if you are changing your editor, there you may or you may not follow this rule. So it's up to you. But this is a standard rule that when you are writing a Python, every function definition will skip 2 lines and you continue with this. Okay. Okay. So now you probably now know what functions are and how they are getting executed or how they are getting called behind the scene. Today we want to explore function a little bit more in depth. Okay. So let us see what happens behind the scene. Let me open a paintbrush here, and there we'll start writing, or there we'll start creating a small diagram. So understand this from the memory point of view as well. This is crucial rather. And to understand this, I think, okay, I'll take an example of function 1 first. So I've created a function 1 there. Now probably I'll just take that function 1. Maybe I don't need this for now. Just let me copy this and let me put it here. So this is the function I've written. I'm going to put that function right here. And let me see what happens behind the scene. Actually, and to be precise, I want to show you 2 examples. So it's better we can just move it down. And then along with this, I want to show you one more example where we are saying num is equals to 100, for example. You know, num is equals to 100 means it is an integer variable. I'm sorry, integer variable. And if it is an integer variable, I can simply print the type and the value of it by saying this is num. Sorry, I should have said f. And then I can print the type of it as well. This is something we already have explored earlier as well. But today I just want to put more light on how the variables are getting declared behind the scene and what happens when you declare a function. Because there are a couple of different advanced topics which are dependent on this discussion. So let us see what happens here. It's very simple variable, num is equals to 100 and the data type is equals to, my bad, I should have said type of num and then I'll get the type of num as an integer. So let us see what happens here. To understand this, I'm going to take these 2 examples. So this is my first example where I'm declaring a variable, and this is another example where I'm declaring a function or I'm defining a function precisely. So let us see what happens when you are doing something like this. Now, the moment you declare a function, declare a variable. So this is the variable declaration part. Behind the scene, Python allocates a memory. So this is the memory allocated in your RAM, for example, which is going to be used for storing the value 100. So this is a memory, and inside this memory, the value gets stored as 100. So this is the 100 value, which will get stored right inside this particular box or this particular memory. So this is how it goes. So this is the value 100 and which is getting stored right inside this. Now, this is a memory. When I say memory, the memory will also have its own memory address. And if it is a memory address, I'll just go back here and I'll say this is 0x, let's say 10,000. Memory address is a random address. I'm just taking an example here, something like a 0x 10,000, and I'll put it right here. So this is the memory address. I think it's better I can change the color. Maybe I'll use a different color for memory, value, and the actual variable. So let's say green color is the address. So this is the address of that block where the value is getting stored. The value is 100 and the address is 0x 10,000. Now behind the scene, whenever you are using num, the num will be referred by using this memory address. So behind the scene, I'm going to say that this block itself will be declared as or will be renamed as a name. So whenever you say num, by default, it is going to use the memory address 0x 10,000. Now, this is nothing new to you because I hope in other programming languages also you have seen the same thing. So almost all programming language work in the same way. So they create a variable in such a fashion that the variable name is for you, and for Python or for language or for executable, it will be always the address. This is just for an alias, or you can say this is just for you to understand that, okay, I'm referring a memory location at 0x 10,000 location, which is having a value equals to 100. So basically, when you run this code, something like Python print blah, blah, blah. I don't need this right now. So I'm going to delete this for now. And probably when you execute this, this code here, probably what happens here is when you say you are printing the value num. So what does it do? It goes here and it reads the value at this particular location. So basically it goes to that 0x10,000. Num is for you. For Python, it is 0x10,000. So it goes to that memory location and it prints the value equals to 100. So that is how it goes. That is how it does the job. Now, not only this, I'm going to show you one more detailed example of it. This is something which is very simple to understand. Now, there are a few more things that happen behind the scene. Guys, are you paying attention? Are you there? All of you, can you just confirm whether you are there and whether you are getting the point? Okay, very good. Just want to see whether you are there. This is a little bit theoretical, I know, but this is a conceptual part. If you can understand the concept, I can bet on that there are almost 6 to 7 topics which are dependent on this. So if you can understand this, all the topics will be automatically clear. So when you are running an application, I hope I mentioned that last time, when you are running a Python application, especially, your application gets compiled, because Python is not only an interpreted, it is a compiled and interpreted language. So behind the scene, the code gets compiled. Now, when you say the code gets compiled, while compiling the code, whatever it finds in a sense, the Python 3 or whatever the compiler finds inside your code, it just starts noting it down. For example, if I look at the code, it finds that, okay, there is a variable called as a num, or there is a function called as a function 2, or there is another function called as function 1, and so on and so forth. If you can recall, on day 1, I mentioned whenever you are creating or whenever you are writing the code, probably behind the scene, all the code statements will be having one or more identifiers. Identifier can be a variable, identifier can be a function name, identifier can be a class, or identifier can be anything. So behind the scene, all of them are nothing but the identifiers. So what happens here is, whenever you are compiling your application, the Python compiler looks at your code, scans your code, and finds all the identifiers in your code. So probably this is a kind of a table where it starts putting all of them into one single place. So for example, this table here, generally called as, and again, this is not only for Python, this is a language neutral. In a sense, every language is going to have this particular part there. This is called as a symbol table. So every language has it. Python also has it. So this is a kind of symbol table. Now, what will you find in the symbol table? There are almost like 30 fields in the symbol table. We are not going to bother about all of them. We are just going to look at only those which are required for our discussion. The very first thing it uses, or the very first thing it puts in that table, is something like a symbol name. I'll simply say it is a name. So whenever it finds a symbol is kind of an identifier. So for example, num is an identifier, it calls it as a symbol. Function 1 is an identifier, it calls it as a symbol, and so on and so forth. So whenever you are creating a class, function, variable, all of them for Python are nothing but the symbols, or are nothing but the identifiers. So it collects all the information and it puts that in one single location called as a symbol table. Fine. So this is the name. Now, next to that name, it finds out what is the current value that you have assigned to that variable. So probably I have assigned value 100. So I'm just going to say that current value, or you can say the value, whatever you can say. It's better I can say it as a value. So maybe I'll say that this is the name and this is the value. Whatever the value you are assigning to that variable, it will be pushed here, or it will be added right next to that name. Other thing is like looking at the value, it also says what is the data type associated with it. So probably the next column is nothing but the data type. And why data type is required? Of course, you have to have a data type for a variable. Either you explicitly create a variable with a data type, which is not possible in Python, which is possible in other languages like C or C++, or let the language decide the data type for you. But data type is mandatory. So this is the data type. And finally, it also mentions on which location the variable is created, or the variable has allocated the memory. So probably this is a memory address. Unfortunately, I can't show you that address, at least for now. It's just because in Python, pointers are not supported. I don't know whether it's a sad or whether it's a good news for you, but whatever it is, Python does not support pointers, unfortunately. I know you people like C, or you people already have learned pointers and you love pointers. Being psychiatrist here, but yeah, I know this is how it is going to do the job. This is a table. Now this table will have all the symbols it is going to find in your code. So probably this is my table. All of these are columns, and right inside this table, it is going to start creating different rows as and when it finds a symbol or an identifier, it just starts marking it right here. So this is my first symbol, this is my second symbol, third symbol, fourth symbol, and so on and so forth. So this is how it is doing the job. Okay, so probably if you see here, we have almost like 3 symbols in our code. Now when I say 3 symbols, we'll start scanning the code first, see what happens here. So when you say there is a num, it starts adding an entry here. So it says, hey, I found a num. Now what is that num? Okay, so it says that num is a variable. So num is equals to something, that means num is a variable. So it puts that num here. What is the value you are having here? I think the num is having a value equals to 100. So it creates a memory allocation, or it allocates the memory. It puts the value there, 100. It calls it as a num, and this is the memory address. So it says, it seems like the value you are setting it to that variable is 100. So this is how it puts the value 100. Now it understands the value is equals to 100. That means it looks like an integer. So it assigns the data type as integer. So this is how it does the job. And then it also puts the memory address of that variable, which in my case is 0x10,000. So I'm going to put that memory address right here. This is what you might see in the Python behind the scene. I mean, you will not be able to see that actually, but this is how it does the job behind the scene. So this is the symbol table, and that symbol table helps you to get all the symbols found in your code. This is the symbol table. Now let us see what happens. Now tomorrow, if I change the value, let's say earlier I was having a value equals to 100. So probably if I change it to 200 now, and if I try to print the value again, so probably if I run this code, you see that earlier it was 100, now it is 200. So what has happened here? So probably when you say num equals to 200 again, so this was the case earlier, but if I say num is equals to 200 now, so behind the scene again, it is going to, let me just put it right here. It is going to change the value. So what does it do? It does something like this. See if you can understand that. So this is exactly the same num we have created earlier. Now I'm just going to show you the second scenario. This and this is exactly same. Don't get confused. This and this is exactly same because I'm going to use the same memory address. So earlier it was 100. I think it's better I can just make it little bit smaller. So I'll say that this is 100. It was the value we were having earlier, but now it's not 100 anymore. So that was 100 earlier, but now it is 200. So what does it do? It wipes out that 100 and it puts the value 200 there. So it says, hey, 100 was the older value. It wipes out that value here and then it puts the value here. Of course, it updates the value as well. In a sense, it just goes back here and it says that 100 was the older value. So it removes that value and it puts the value 200 here. So this is how it does the job. So probably whenever you are dealing with your variables behind the scene, Python plays with that symbol table and Python keeps on updating it whenever there is a change in the variable's value or whenever there is a change in the variable's declaration or variable's data type. So this is how it does the job. Now probably you can see that we were having a variable with num with value 100. Now we are having the value 200 inside the num. That means the data type is not changed. The data type is still integer. And this is integer because you know the 200 is also a part of integer data type, or it's also a kind of integer value. The value or the address is not changed. The value is changed, fine. I can see 100 is changed to 200. Data type is not changed, and also the address is not changed. It just change in the value. Yes, it does every single thing dynamically. So whenever you are doing something like this, it changes the values dynamically like this. Okay, now when you are doing something like this, probably let's see what happens with the function. Now, when you talk about the variable, this is exactly what happens behind the scene. Now, let us see what happens in case of function. Now, function, it's a little bit different. So pay attention and see what does it do. Now, in case of function, when I declare a function like this, maybe I say this is the definition function 1, which means it has found one more symbol. The symbol name is function 1 or identifier name is function 1. So this is my function 1. The function 1 is a symbol. The function 1 is the name of my identifier, for example. So I'm going to put that function 1 right here and let us see what happens now. Now, when you say you are declaring a function behind the scene, again, it has to allocate the memory. So behind the scene, it has to create not one, but two memory allocations. See, what does it do? So when you write this function, for this function, it creates two different memory locations. So probably 1 and 2. 1 is used for storing the actual, maybe the actual reference. I'm going to show you like this way. Maybe there is a 0x20,000, for example. This is an address of this particular memory block. There are two memory blocks. This is 1 and this is 2. Let's say this is 30,000. I'm using some random memory addresses. Memory address is not important. Important thing is the concept. See what happens behind the scene. So now there are two memory locations, and inside this memory location, inside the other memory location on the left hand side, it puts the function definition. So I'm just going to move this here. I don't need that comment right now. I'm going to need this one only. So let's put it right here. And probably I'll just make sure that it fits in that box. Okay, so this is how it does the job. So it creates a memory block and it puts the function definition here. So probably you can see that it is loaded that function definition on 0x30,000, for example. Now it puts that memory address 30,000 into the other box. Now when I say into other box, it does something like this. Probably you can see that the 30,000, if I put it here, that simply means this box will have, or this box will point to a memory address which has a 30,000 address, something like this. So it points to a memory which is allocated on 0x30,000. You see that it is a kind of one box which is having a value of 30,000, and this 30,000 is pointing to another box where the actual function body or the actual function definition is loaded. Now why there are two boxes, I'll mention that later, but right now see what does it do. So basically it does something like this, and then it calls it as a function 1. See, this is where I'm going to say this is the function 1. Now what is it? This is the variable, or this is, you can say, sometimes called as a reference. A reference which is going to talk to, or which is going to point to the another memory block where you will find the function's code. So this is the reference. This is also pointing to another memory block where the actual function body is loaded. This is what exactly it does behind the scene. I know you might be having few questions like, why two boxes? Why not to do something like that num? Why it's wasting the memory? It's not wasting the memory. There are few concepts which are dependent on this particular concept, or which are dependent on this particular boxes or this particular format. So let us see what does it do. Let's ask that question why later. First, let's say what and how. So what does it do? It does that something like, it does allocate something like two boxes, and in one box, it puts the address of another box. The box where it puts the address of another box, we generally call it as a reference, and this is nothing but the function 1 for me. In the other box, when I say 30,000 is the memory location of that box, in the other box, it puts the function definition. It does this behind the scene. Let's see what happens now. Now it says that because it found that function 1 is associated with the def keyword, it says, oh, it seems like it is a function. So it changes its data type, and it says that data type of this function has to be a function. So it does something like this. What is the value right now? The value is 0x30,000. Means for us, it's kind of a value, but for Python, because the data type is equals to function, this will be considered as an address. So basically the value inside this is 0x30,000, and where it is allocated on 0x20,000. So this is how it is going to update the symbol table like this. Probably you can see that what it is doing behind the scene. Behind the scene, whenever it finds a function, it creates two memory blocks. It allocates two memory blocks. One block will be having the function definition. The other block will be having an address of the other block, and this block will be called as a function 1. Like I said, this is the num. This box is called as a num. This box is called as a function 1. So wherever you are referring function 1, it will come back to this block. Then it will go from here to here, and then it will continue further. By the way, this symbol table will be loaded in the memory. So there will be no hard, you can say hard copy, or there will be no physical copy of it. It will be loaded in the memory, and once the program terminates, it automatically tear down that symbol table. precisely the symbol table gets created or gets loaded in the memory. So you will never be able to see that, but believe me, it will be there in the memory. So now it seems like we are having two identifiers. One is the num and the second one is the function one. What is the difference between these two? The main difference is one is of type integer and another one is of type function. So you might say, what's the difference then? The difference here is whenever you are talking about a data type other than function, one more time, whenever you are talking about the data type other than a function, then the data type or the type of variable will be considering this as a value inside it. If it is a function, then it will consider it as an address to it. Let me repeat myself. When I say the data type is integer, the value column will tell you the value inside the memory. And if it is a function, then the value column will be considered as an address to the memory, address to another block in the memory. So this is how it does the job. Now you might be wondering, like last time I tried to show you the data type of that num. It worked. I saw the data type. I saw the data type as an integer and it worked. Now I want to do the same thing for a function. Please pay attention. This is a little bit different. You must not have seen this in other languages because this is supported in very few languages. Those are called as a functional programming languages. So let us first understand what exactly do you mean by this function here. Is it a function name? Is it a symbol? Is it an identifier? What is it? Let's see. So for me, num is a variable which is storing a value 100. And for me, function one here is a function. So this is the def, so it is a function one. But let's see what that function means for Python. So I'm going to come back here and say print. See what I'm trying to show you. I'm going to say function one is equals to function one. Pay attention. I am not calling a function. I'm just using the function one as its name. And along with it, I can put that in the same line, but it's better. I can put it on the separate line so you can see this clearly. I'm going to say the type of function one, which is equals to, like I said, the type of num, I'm going to say the type of function one. Please make sure that you are not calling the function. So basically here, I'm using only the function's name because for me, function's name is nothing but the address. The address is 20,000. So the address here is 20,000, this 20,000. So it goes to this memory address and it will try to show you the information about it. Let's see what happens now. So probably I'm going to run this code and here for the first time, you see that this is the num. This is again the changed value of a num, which in both the cases are having the data type as an integer. Now let's take a look at this function one. The function one is a block or is a kind of memory address somewhere here, which is pointing to, this is of type function, which is having a name function one, which is allocated at this particular memory address 0x10,000 blah 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 blah. So whatever it is, 1056 BD1E0. So this is the address of that block. For me, the address is 0x20,000. This is the real address that you might see in your computer. And on top of it, can you see that the type of function one is a function? So for the first time, you might have seen this. When you are talking about the function, you can also get the type of function as well. So the type of function one is a function. Now, probably if you have understood this diagram here, it is really simple to just understand what happens behind the scene. If you want to get the type of num, it simply goes to this column and it takes out the data type of it. When you want to find the data type of function one, it goes to that particular row and then it finds out the data type of it, which is already a function written in this table. So probably whenever you are talking about the type of function one, it says that this is a function one. Not only this, probably if I come back and say print, just go for the second function, function two. Let's see what does it show here for function two. It has to be a function again, but I just want to be clear. So type of function two, which is equals to, again, type of function two. Don't need to call the function and we should not call the function. We just simply need to print the data type of it. Again, let us say run, and no wonder you see the data type of function two is again something like a function. Again, function 1 and function 2, both of them must be loaded in two different memory location, because they have to be they have to have a different or unique memory address, because otherwise you will not be able to identify them uniquely. So whenever you are declaring or whenever you are defining a function, that function will have two boxes, two memory blocks, one to hold address of another block where the actual function body gets loaded. Okay, I know it's a little bit difficult to understand for the first time, little bit difficult to digest for the first time, but believe me, when you digest this, there are many concepts which will be cleared easily. So whenever you see a function, don't try to see it as a function. Behind the scene, that function will be treated as, or the function one or the function name will be treated as a variable which will point to another function's address. So probably whenever you think of a function starting from today, don't just visualize it as a simple memory block which is having a value in it. No, behind the scene there will be two memory blocks where the actual memory or the actual function body will be loaded and address of it will be added into another memory block. This is how it does the job. Okay, let me repeat quickly what I said earlier. To repeat it, instead of repeating it for function 1, let me repeat it for function 2. See what does it do. So this will give you a chance to again understand it one more time. So probably I'm going to come back here. This is the another function we have seen last time, a little bit bigger. Let's see whether it can fit here. Oh yeah, it fits. Very good. So this is the second function. This was the first function we created earlier, function 1. Now we are going to deal with the second function. See what does it do and how does it do that. Okay, so whenever you are talking about a function, no matter how many lines of code you have written in that function, no matter how simple or how complicated that function is, ultimately, whenever you are talking about a function, the same story gets repeated all the time. So probably what does it do? Let us see it here. Again, behind the scene, it is going to allocate two memory blocks. Let me use the same color I used earlier. This is the first memory block, and this is the second memory block. So again, whenever you are talking about the function will be splitted into two memory blocks, one to store an address of another block. I know you feel like it is a redundant, you are wasting your memory, but it's not the wastage. It's a kind of investment for do some other kind of business. We'll see what that other kind of business is in a moment. But first, let's explore this and find out what happens with that function 2. So this is the function 2. What does it do now? See, it ultimately loads that function 2's body somewhere here. Let me make it a little bit smaller so I can fit it inside this. Okay, it seems like there is no space left here. Maybe I can just take it out. I hate writing this kind of code, but it's okay, because you might have seen that whenever I write the code, it is always indented, it is always having all the spaces, and it looks always good. I mean, this is something which I follow all the time. So whenever I write the code, I always follow these kind of rules, and I would encourage you to follow as well. Anyways, so this is the function 2, and in function 2, this is the memory block. Just for example, I'm saying this is allocated at 50,000. Again, just a random number. Huh? So this is 50,000, for example, and this is again green, because I'm using that green color for all the memory addresses here. So maybe I can say 50,000. That 50,000 will be added or will be noted inside the another memory block somewhere here. And probably you can understand now that another memory block, the one which I'm using it here, will be having its own memory address. So probably I can say this is again a green, and I'll say that this is, let's say, 60,000, for example. So again, this is another memory block, 60,000, which is storing the value of 50,000, which is an address to another memory block where the function 2's body is getting stored. Now, probably what do you call this as? This is nothing but my function 2, which is a reference, which I already mentioned last time. Let me mention that here as well. This is called as a reference. Okay. So this reference is again pointing to the memory block where the function 2's memory or function 2's body is already loaded. So this is how it does the job. Don't forget, it always updates this table as well. So it goes here, it says that it has found a function or as identifier as function 2. So it mentions this here. The value in this case is 0x50,000 because it is having that value there, 0x50,000. Next, the data type of it is a function. We already have seen that last time. So let me come back and say this is the function. And probably there is one more, that is an address of it, that is again 60,000. So on 60,000 memory location, it has allocated a reference with the name function 2, which is having a value of 50,000. And 50,000 is not actually the value, but it is an address to the memory block where the function's body is loaded. So probably looking at this particular table and looking at two different scenarios or two different examples, you might see that what happens beneath, what happens behind the scene when you are creating or when you are declaring a function in Python. Guys, can you please give me a confirmation whether you have understood this or not? Yes, very good. Because unless you understand this, I can bet on that next topic is pretty much difficult to understand. Generally, people try to study the other topics without understanding this, and that's the reason the other topics become a little bit confusing and little bit difficult to understand. See what happens now. If you can understand that, I can make a conclusion out of it. The conclusion here is, even though you are declaring a variable or you are declaring a function, all of them are by default considered as symbols. All of them by default considered as identifiers, and all of them are already making their room or making their entries inside the symbol table. So symbol table is the one where you are putting all of these found identifiers along with the value, along with the data type, along with the memory address, and so on and so forth. This will be created at the time of compiling your code. This will be used all over time whenever you are using different variables, different functions in your program, and whenever your program terminates, the symbol table also gets terminated. This is again, it's not only in the Python, it will be always there in all the languages. The only difference is, listen to this difference again, and not necessarily we have to discuss it here, but anyways, we are talking about this point. So let me tell you, when you are using another language like C or C++, where you are creating the executable, this symbol table gets added into the executable itself. I don't know whether you have seen this or not, but every executable will have its own file header. The file header will contain all the symbol tables like this. Of course, the symbol table will not get modified inside the file. This will get modified in the memory. So this is a little bit difference between the other languages or compiled languages and the Python. Python being an interpreted language, it's not only interpreted, the first compilation happens, and at the time of compilation, it creates a symbol table, it loads that in the memory, and whenever you are referring to these variables, it keeps on referring it and keeps on updating it all the time. So whenever you are done with this, or whenever you are done with the program, or whenever you are kind of finished with the program, it terminates that symbol table. So that's how it does the things behind the scene. So again, look at this. Even though you are declaring a variable, it allocates the memory and it treats it as a variable. And probably when you are declaring a function or function 1 or function 2 or any function, here also it treats that function 1 or the name of that function as a variable, which is pointing to another memory address, something like this. Okay. What is that? Okay, symbol table is created and maintained while compiling. Yes, it will be created and maintained at the time of compiling. It will be destroyed at the time of destroying or at the time of terminating your application. What about P1 and P2? P1 and P2 will not be here. P1 and P2 will be there when you call the function. Again, I'm not going in that details because that is pretty much similar for all the applications. Whenever all the languages, whenever you are creating a function or whenever you are calling a function, one stack will be created, and on that stack, the P1 and P2 will be allocated. So again, Nidhi, we don't have to talk about the P1 and P2 because that story remains same. Here, this is a completely different, or that's a game-changing movement for Python. So Python has done something like this, and because of it, you see now what other things is possible. Okay, let's see. Anyway, so let's come back here. Out of two addresses, which address given by the function? Out of two addresses, you're talking about maybe this one and this one. This is the address where it has already loaded the memory. For example, 30,000 here or 50,000 here. This is the address where the function's body is loaded, and this is the address where the function's reference is created. You call it as a reference or you call it as a variable to that function. Both of them are absolutely same. Okay. Prerna, you're saying it should be 30,000 as a default function, as its value in the function 1. as its value in function 1? Absolutely. So function 1's value is 30,000 and function 1's address is 20,000. This is an address of function 1 and this is an address of the body where the function 1's body is loaded. Okay. Who called the symbol table? Compiler operating system. It's not the compiler, it's a PVM. PVM uses it. Compiler creates it and PVM uses it. Okay. Who's that, Vipin? Can we say the functions here are the variables of reference type? Absolutely, yes. And yes, Vipin, I think you got it right. I can't use that reference type and value type right now because for that we have to go to OOP. When we go to OOP, I'll make it precise saying this is a reference type. So other than that, I think if you are getting it, you're absolutely right. Absolutely. Okay, Tanya, your question, how is the symbol table gets loaded in the memory? It gets loaded in the memory at the time of compiling your code. The compiler creates a symbol table, it loads that in the memory, and whenever PVM needs it, it will find all the information from that symbol table. Stack, heap, or free malloc. It uses the stack. By the way, when you are using Python, all of these things will be loaded in the heap section. Okay, stack is used only for the function. So when you talk about the function is getting loaded, at that time stack is used, but this one will be loaded in the actual heap memory because the PVM itself is getting loaded inside the heap memory. That's how everything goes in the heap. I think malloc and calloc is not there in the Python. Of course not. Malloc and calloc are there in the C, and these are there because you are using pointers in C. That's the reason. Okay. Can you please explain the diagram once? I think I explained this twice, but if you really want to highlight something, just tell me that. I'll just put more light onto it. Okay. Where are the variables stored inside the heap memory? Where in the heap memory will be stored? That question I'm going to put on hold for now. I'm going to park that question because I have one more session precisely allocated only to talk about the PVM's architecture. There we'll see in the PVM, there is a separate memory allocated called as a heap memory. In that section, all of these things go. Okay, so Tanya, just put that particular question on hold. You will get an answer later. Okay, I'm not clear with this concept in C, so having a problem to understanding. Forget about C because now we are not going to compare this with C. This is how it happens in Python. Okay, so if you try to compare two different languages for internal memory representation, it might be a little bit confusing because you are comparing apple with orange. This is an interpreted plus compiled language. C is pure compiled language. So you're not comparing two languages of same type. These are two different languages. That's why you might see a little bit confusion here. Okay, so don't try to do that. In C, it completely handles in a different way. Here, it handles in a different way. Okay. Agree. Yes. No problem. Combo. Okay. Python does not add a pointer here. Pointer feature. No, Python doesn't have a pointer here. I don't know whether it's a good or bad news for you, but there is no pointer concept here. Okay. Okay, now let us continue further because I know the questions will not end. There are many questions and I hope all of your questions will be automatically answered as and when we discuss the few topics there. Okay, just bear with me. There are many things which are required to discuss. Yes, you are raising your hand. Do you want to say something? Do you have anything? You are raising your hand. Just saw that.
Yes sir, I want to ask one question.
Sure.
सर आपने जो अभी फंक्शन का एड्रेस जो प्रिंट किया था पिछले कोड में, वो उसका रेफरेंस का एड्रेस प्रिंट हुआ था या उसके जो डेफिनेशन जहाँ पे सेव है उसका एड्रेस प्रिंट हुआ था?
ये उसके रेफरेंस का था. In the sense, the one which you see here, 20,000 or 60,000, that is a type of this memory address. So this memory address is of the reference, and the reference will have another memory address inside it. Okay.
सर तो मतलब वो 20,000 ही प्रिंट हुआ था ना?
हाँ, exactly. So 20,000 or 60,000, whatever you say here. 20,000 for function 1, 60,000 for function 2 is nothing but 10, 15, whatever it is for function 1 and 10, 16 for function 2. Okay.
Thank you, sir.
Yeah. Unfortunately, I will not be able to show this address because Python does not support pointer. That's what I said. Okay. Really cannot understand where and how apply this concept in the Python. Shripati, that's what I said earlier. If you can hold your patience, you'll be able to see it. I mean, right now, just see how it does it. Later, in a moment or two, you will see why and how Python uses this concept. Okay, Shripati, I will appreciate if you can hold your patience. Okay, let's see. So let us see why we discussed it and how Python uses it behind the scene. Now, one thing is clear, that you declare a variable or you declare a function behind the scene, it is going to allocate at least one memory block which contains a reference to that value or reference to that particular function if it is a function. Okay, now let me come back here and show you a couple of different things. See if you can understand. I'm going to create one more page here. This is going to be a page 2, and right inside this, I'm going to start writing another function. Okay, pay attention. I'll say before I talk about the function, I'll create a simple variable. I'll say num is equals to 100. I'm going to say print one more time. I know it's repetitive, but it's okay. It's easy for comparison. That's why I'm going to put this example here as well. This is type of num. And let me say this is num2 is equals to num. Now I want an answer from you guys. Like if you say there is a num and there is a num2, can you please tell me what will be the answer of this code? What will be the type of num2 and what will be the value of num2? Any guess? Exactly. The data type of num2 is always integer and the value will be something like 100. Absolutely right. You got the point because it's very simple to understand, right? Now see, Shipati, your answer is coming. So let's see. I'm going to create one more diagram. Before that, before I forget it, let me save that in your directory. So it will be easy for me to share with you later on your Git. So it's workshop. We are in Python 04. In notes, today is what? September 4. So SCPT4 _1. That's a diagram. I will be sharing with you later. Let me create a second one here and let us see and let us compare what is going to happen with this example. So I'm going to have these two num1 and num2, or num and num2 precisely. This is num and probably this is num2. So let's come back here and say this is num2. So let us see what happens here. So basically when you say num, it is exactly similar. So what I'm going to do here is I'm going to simply copy and paste it here. So for me, this num is having almost the similar representation. Now, because we are creating a num2, this is how it is going to do the job. So probably what does it do? It simply says, this is the num, this is the num2, and this num2 will be having its own memory address. I'm not going to talk about the symbol table anymore because you know what happens behind the scene now. So it automatically creates a memory block. It automatically updates it behind the scene. For me, the important thing here is this. So this is another memory block because this is another variable we are creating. So let's say this is another variable we have created and this is called as num2. Okay. So num1 and num2, both of them are different variables. Both of them are different variables, but let's see what we have done here. We have said that num2 is equals to num1. So first it allocates a memory and then it says copy the value inside num1 num into num2. So what is the value? The value here is 100. So this 100 value gets copied inside the num2. Now naturally, because the value of num2 is 100, the data type of num2 is also an integer. So basically if I run my code, you see that both num1 and num2, or both num and num2 are having the value 100 and the data type as integer. Now this is another question to you. Let's see whether you can answer this quickly. I'm going to say num is equals to 300 and probably I want to print both of their values one more time. So this is num and this is num2. So can you please tell me, if I change the value of num to 300, will num2 change its value? Of course not. Let me verify it. Can you see that we have changed the value of num to 300 and now the num2 is still 100. Okay. So what has happened here? When you say 300, actually speaking, this 100 is kind of removed and this in this place, let's say 300 value is stored. So this is 100 before, this was 100 before, and now this is 300, not 1000, this is 100. So this was 100 before, and now it becomes 300. So let me put that 300 again. So earlier there was 100 value, but now we have kind of replaced that value with 300. That means num has changed its value to 300, num2 is still 100. That is the scenario. Now let us see what is the similar case in case of function. Pay attention now. This is the game-changing moment. Let's see what happens here. I'm going to create a simple function here. I'll say that this is my def function 1. Watch what happens. Again, there will be a documentation string and all of that thing. I don't care about that right now. What do I care about is the functionality. I'm going to say inside function 1. Say I have a function here. The moment I create that function, I'm not going to write it again. I already have done that earlier. So I'm just going to copy and paste it here. So probably I'll just say that this is my function that I have created earlier. And this function is, I mean, it looks like something like this. It looks something like this. I need some space here. So probably what I'm going to do here is this. Let me just put it a little bit on this side. Okay, so this is something what you have seen earlier, and this is exactly the thing what is going to happen again. So probably I'll just say that this is pointing to this particular memory location. This is the function one inside function one. This is how the current implementation will show you, or this is the current implementation's memory structure inside your RAM. Now, because I already have said that a function one will be treated as a variable. One more time, a function one is treated as a variable. I'm going to come back here and I'll say that, watch what happens now. I'm going to say that this is my function, which is equals to not 100, not num, but a function one. So this is what I'm going to do now. So probably whenever you are writing a code, in this case, I assume that function one is a variable, and it is a variable. I don't have to assume it. We already have explored this earlier as well. So like num, Python consider this as a kind of a variable or as a kind of a symbol. You can call it as an identifier, variable, symbol, whatever it is. So it identifies it as a variable, and it says that this is a variable now. If it is a variable, like num, I can use it as a variable and I can assign it to another variable. So I said num2 is equals to num, assuming num was a variable, and with that variable's value, I could create num2. Similarly, for me, I'm considering function one as a variable, and I'm creating one more function or one more variable to that function, something like a my function. See what happens now. So moment I say my function is equals to function, something like this, see what is going to happen in the memory. In the memory, it is again going to create one more block which looks like this. What is going to happen here? Again, this will be considered as my function, like what we have seen earlier, and probably you might have noticed it now that this function one is again a kind of a reference. I'll call it as a reference because you will see that in a second why a reference, and probably you will also see what does it do in actual memory block. Let's see, it has another address. I mean, it's a unique memory address. So probably I'll say this is 0x I think I used 2000 here. Just give me a sec. This 200 and 2000 they should not clash. I'll use something else. I'll say 0x4000 or 40,000, whatever. And probably this is where we are going to say here, and behind the scene this is 50,000. So probably this is another memory address. This is another memory block allocated in the memory. But now see what happens. I've created a variable for my function. This is it. And now we are saying inside my function, add the value which is there inside function one. What is there inside function one? It seems like there is 0x30,000. So if it is 0x30,000, simply copy as it is 0x30,000. And guess what? This is exactly what happens now. And probably you can imagine this 30,000, this 30,000, both of them are nothing but the addresses to the same block. Are you getting something? You can say that your function is, or your another reference, my function is pointing to the same function block we have created earlier. So probably when you are doing something like this, the assignment or creating a separate variable like this, which is pointing to exactly the same function which we have created earlier. This is exactly what is going to happen in the memory. So whenever you are in Python, the Python's address, the Python's function is considered as a variable, and that variable is pointing to another memory block where the function's body is getting loaded. And when I say my function is equals to function one, this function one's address, this function one's value gets copied inside of this, and literally it copies the value right here. So this is how it does the job. Probably you can see that it has copied the value from this to this. Exactly what we have seen earlier. We have copied the value from this to this. So exactly the same thing has happened here. And now both of them are pointing to the same memory block or the same function address. What do you mean by that? Exactly in this case, let me just come back and show you something. This is my function, F capital. This is the name actually. So I'm going to put that my function here again. And like last time, I'm going to say this is the type of my function. And I'll say the type of my function. I'm going to do the same thing for function 1 as well, because we already have seen that last time. It will be easy for you to understand. So this is the function 1. I can say this is the function 1. And probably I'm going to do that here. This is function 1 and type of function 1. Let us see what happens. When I say run, probably you can see that the function 1 is loaded at this memory location. You see, my function 1 is also loaded at this particular memory location. So they both are pointing to the same memory location, exactly like this. Guess what? If it is the case, 1 is a function, second one is also a function. Pay attention to this one. Both of them are the functions. Both of them are the functions means what? Now, this is something that I wanted you to understand. This in case of Python is called as a function alias. The function alias means it is another name given to existing function. In a sense, now henceforth, I have two ways to reach to that block. I have two ways to reach that memory block. In a sense, I can call that function by saying function 1, which means I'm going to visit this and then going to call that function. And I can also say my function and call that function. And guess what? See, my function is getting called twice inside function 1, inside function 1. One due to this memory block and second one is due to this memory block, or one is due to this reference and two because of this reference. So probably if you pay real close attention, now we have given one more name to the function. When I say one more name, my function here is acting as a variable which is storing the address of the actual function. Guys, are you getting the point here? Prashant, of course, we are going to look at ton of real-time examples. Without those examples, this particular concept is of no use. So to understand those real examples, I'm creating the foundation. And believe me, when you look at that code, probably you will definitely appreciate the one we are, the diagram we are drawing here. So the other concept, map, filter, reduce, lambda, all of these concepts, generator, decorator, all of these concepts are dependent only on one single concept here. There is entire module, there is entire package called as a Flask, which depends on this particular functionality. Actually, Flask depends on decorator, decorator depends on function alias, and function alias is what we are discussing right now. And without Flask, you cannot create the REST applications. So probably this exactly is what you are going to see in the real-time examples, in the real-time code. But behind the scene, what happens, if you can understand it, the real-time code will be easy for you to understand. Anyways, coming back to the point here, when we say my function is equals to function 1, my function 1 is getting an address of function 1, and that's how it is pointing to the same memory location. So again, in case of num1, num2 is equals to num, it is creating a separate memory location like this. Sorry, it's creating a separate memory location like this, and it is copying the value of num. Exactly same thing happens here. When you say my function equals to function 1, it creates a separate memory location, but it copies the value inside it here. And because of this value, 30,000, 30,000, both are pointing to exactly same memory location. And that memory location is nothing but where the function's body is loaded. Okay, so now henceforth, I can reach to this memory block either by walking this path or otherwise walking this path. So where you are coming from is not important. Where is your destination? That is important. So even if I say function 1 parenthesis or say my function parenthesis, like what I just showed you here, function 1 parenthesis and my function parenthesis, it is exactly going to reach to the same destination. because both of them are having the same memory address. One more time, for those who are coming from C or C++, for them, this is exactly similar to a function pointer. Absolutely. Rajendra, Prashant, yes, that is exactly similar to a pointer, but it's not the pointer we are discussing here. It's the functionality called as function alias we are discussing in case of Python. This is called as a function alias. Function alias is nothing but another name given to an existing function, and that's how it does the job. You can call it as a variable to a function. You can say this is the variable to a function. Okay, so variable to a function, another name given to a function is exactly a same thing, and this is how it does the job. Guys, are you getting the point? Jenica, you are saying my function does not rename the function one. No, it's not renaming it. It's just another name. This is another name in a sense. For conceptual point of view, this is another name. But from a technical point of view, this is another reference to an existing function. It's like both of them are having the address of same memory block. So both of them are pointing to the same memory block. You call the function one or you call the another function, my function one. Ultimately, they will reach to the same memory destination. Janika, are you okay with that? Yes, you are raising your hand. Sorry, I didn't see that. Yes, you can unmute yourself.
सर कोड का आउटपुट दिखाइए ना सर, वहां पे दोनों का एड्रेस सेम प्रिंट हो रहा है.
Exactly, I knew it what you're talking about, and this is why, I mean, this is something which you're talking about. 0x94, 0x94, they both are talking about the same memory address. The point here is both of them are addressing the same function, So ultimately, you talk about this or you talk about this, they are talking or they are pointing to the exact same address, exact same memory location. That's what you are talking about here.
Sir, आपने जो पिछला कोड किया था उसमें तो
exactly. I know what you're about to say. Last time I said that this memory location is of the reference, and yes, this is true. This is exactly the same memory location you are talking about. Now, this is a kind of theoretical, or this is a kind of memory, or this is a kind of understanding point of view. To be precise, do you think that the Python or the language is stupid enough to create us or to waste another memory location here? What does it do? Whenever it sees that it's the same memory address, what does it do? Instead of creating one more block here, instead of creating one more row here, it just uses the same there. Getting my point?
Yes, sir.
This is the language optimization. Behind the scene, instead of wasting one more memory block, it uses the same row or it uses the same address and it calls it as my function. That's what you need to get here. I mean, what I said earlier and what I'm saying right now is absolutely same. The only thing which is different here is this is for our understanding, so that yeah, I can understand both of them are pointing to the same function, but language or the compiler is doing its own optimization so that it will not waste the memory. It will use the existing, because you are saying the same thing, isn't it? You are saying my function one is equals to function one, so it adds the address of function one into it, which means both of them are pointing to the same address. And again, even though you see that the address is same, ultimately this is exactly the same memory block that is pointing to the existing address, or this is pointing to the existing function.
सर मतलब एक ही मेमोरी लोकेशन को दो नाम दिए हुए.
Do you see what I said earlier? Another name given to an existing function. Yes, that's the reason why I said that. You know. Yes, are you okay?
Yes, sir. Yes.
Okay, fantastic. I mean, I was expecting your question because I knew what I mentioned earlier, and I was about to say that, but thanks for asking the question. No problem. I think everyone got clear about it. Again, this is how it does the job behind the scene. Good. Rishikesh, you are raising your hand. Do you have any question?
Yes, sir. I have one question.
Sure.
Sir, what if I pass one argument to function one? Then how will be the calling convention to my function?
Coming back to the point. Just first, do you have any question on this diagram?
No, sir. I was just testing that code on my local machine, so I was getting one error. That's why I thought
I'll talk about it here. I will talk about how to create a reference or how to create a function alias of a function accepting a parameter. Okay, just give me a minute.
Okay, sir.
No problem. Anyways, your question will be answered in the next example.
Okay, sir.
Okay.
Thank you.
Sure. Fayaz, you have any question because you are raising your hand?
Yes, sir, I have a question.
Sure.
So when we are using this function, if we go for like a repetitive function or for recursion, the same will be the case, or there will be different jump statements used here?
It will be same exactly. So even though you are creating my function 1, my function 2, my function 3, all of them will point to the same memory address.
Okay, sir.
Okay, so no matter how many function aliases you are creating, if you are pointing to the same function, they all will point to the same memory block. The same thing is going to happen for the next one. The same thing is going to happen for the next memory block. All of them will point to the existing function. Okay.
So one more question. If there is in case of recursion, will it create a separate memory on stack? Because while recursion, we are always updating the value now.
Exactly. Now recursion is a different case, and what we are discussing here is a completely different case. Recursion talks about the stack, and the function alias talks about the memory block or the memory addresses where the functions are getting loaded in the RAM. Okay, recursion, I mean, if you're talking about a recursion, then you have to talk about how the stack is getting created, how the stack is getting rewinded when you are coming back to the original location. That's a different story. Okay,
okay.
Is it
Yes,
okay if we keep these two examples separate, because these are two different examples precisely?
Okay, sir. No, sir, I was confused about this memory binding between the functions.
Recursion is something which I'm going to talk about in the next session, where I'll show you what happens with the stack. I don't want to add all these concepts at the same time, otherwise it will be a kind of mess, a big mess rather. So let's do it step by step. Today we are discussing about how the function is treated behind the scene. In the next session, I'll talk about how the function gets loaded, how the stack gets created, how the stack frame gets allocated and managed and destroyed when you are done with the function call. Are you okay with that?
Yes, sir. Thank you, sir. Thank you so much.
Absolutely, sure. Janika, you are raising your hand. Do you have any question?
Yes, sir. Sir, I just wanted to understand like how from symbol table someone can know that, okay, I'm talking about my function or function one.
From the symbol table, you're talking about, okay, from symbol table, I mean, again, this is the optimization added by Python, because see what you're saying here. You're talking about my function is equals to function one, meaning you are again going to point to that same function which function one is pointing to. So behind the scene, when you're talking about the symbol table, it just adds one more entry like this. Maybe just for an example, I'm talking about the function one here. So I'll say this is my function, and sorry, my function, this is how it does the job. It just copies the exact same address and exact same memory. That's how it does the job. So this is 30,000 for example. I'm going to put this right here. I'm sorry, not 3,000, my bad, it's 30,000. So this is 30,000 here, and probably that goes here. This is also a function because it is pointing to a function. So the address of the the data type of it has to be a function. And where does it point to? It points to 0x20,000, whatever. I mean, in this case, it is pointing to 20,000. In the other case, it is pointing to 30,000. So see here, this is exactly copy of that row. So probably you can just compare this one and this one, and probably you will see that this is exactly copy of existing function. And that's what it does behind the scene. And that's the reason, probably, Yash, you were asking that question, like why on the earth it is showing the two references having the same address. This is what it does behind the scene. Okay. Janika, you okay with that?
Yeah, sir. If we go back to the output, then
see here,
the function, two functions, I mean, the class name doesn't get changed. It's function one only, like function one at 1094 and function one at 0x1094. I mean,
absolutely.
both function.
Exactly. The reason behind this, can you see that here? Though it is a my function or though it is a function one, ultimately both of them are pointing to the same memory location, 0x20,000, 0x20,000. And in this memory location, what do you find here? What do you find here? You find that it is loading the body for function one. So though you talk about function one, or you talk about function my function, or maybe let's add one more and say this is my function two. Let's say this is function one. Let's add one more and say my function three. And if you say function one, ultimately this is not going to change. So if I just add it here one more time, if I add it here one more time, and I say that this is function two, my function two, and if I added function 3, and if I added here my function 3, this is not going to change. All of them will point to the exact same function. So ultimately it is not going to change that. My function 2, my function 3, my function, all of them are pointing to the same function pointed by function 1. And what the function 1 is pointing to? The function 1 is pointing to a body where the function name is function 1. The function name is not, I mean, it does not matter now, because for you it is my function 1, for Python it is pointing to function 1. That's how you can get it.
Yes, it answers my query. Thank you.
Very good, no problem. Thanks a lot for asking the question. Very good. So now you can understand this part, and now you know what happens when you are assigning one function to or one variable to another function, or another function to existing variable. This is how it solves the problem. And guys, just trust me right now, there are few concepts, few advanced concepts which are dependent on this. Generally I clear this in a couple of first sessions, because if you have this diagram in your mind all the time, many concepts will automatically get clear. You will not have any questions on the other topics. Anyways, so this is a way we are creating a function alias in Python. And in Python, the function alias is the base for couple of concepts. One of the concepts we are going to see now is, let me just come back here and write it here. So see, what does it do? This is a function 3, and see what am I trying to show you here. Probably I want to write a very, very simple example. I want to create, or rather I want to write a function which is going to give me a square of a number. Very simple example. So what I'm going to do here is, I want to write a function called as a square. Now this square function will accept a number and will return a number square. Now how do you return a square of a number? It depends on you. You may say return number star number like this, or number star star 2. Probably you can recall this is something what we have done earlier as well. And I said that this is an operator, mathematical operator, where you can get the power of that number, or it's also called as an exponential. Exactly. So this is where we are getting the numbers power 2, or maybe you are saying the exponent of power 2. Anyways, so when you talk about this square, I think I can call that function easily by saying square of, let's say 9, which is square of 9. I can pass that 9, it will give me the answer, something like square of 9 is equals to 81, as simple as that. Now looking at this function, I mean, it works. There is no problem in that. It works, it gives me an answer. But the only concern I'm having right now is, like, when you are having a small function like this, let's say a square or a cube, or maybe increment or decrement and stuff like that. When you're talking about a function like this, there is a small concern. Like whenever you are calling a function, it unnecessary, just creates a separate stack. It unnecessarily wastes your too much of memory. Now, again, in Python, there are simple functions like this where actual stack frame is not required. The actual memory allocation, or the actual, maybe you can say the memory optimization can be done. And this can be done by using something called as inline functions. I hope those who are coming from C, they might have understood that in C also there is something called as an inline function, the functions which get executed on the same line. So in case of Python, these inline functions are called as lambda functions. So this can be done by inline function, and this in case of Python is called as lambda function. Now what is a lambda function? A lambda function is a function which is kind of executed on the same line. So for example, I want to get a cube of a number. Now if I want to get a cube of a number, it's again almost similar to it. So probably I can come back here and I want to convert this cube. Let's say this is the cube of a function. Let's say this is a number star star 3. This is a cube of a function, and I want to convert this function to a lambda. So let us see how we can do this. This is my original function. Now I want to convert that into a cube. Now to convert that into a cube, we have to use a lambda keyword. So how do we do that? Now to do this, I'm going to say this is a cube, which is equals to, probably you can understand now, a cube here is considered as a variable, which is pointing to a lambda as a keyword. This is the keyword we are using, which is going to take a parameter here. This is the number, the same parameter I took earlier in the other function. I'm using the same one here, that's a number. And what does it return? It returns number star star 3. So I just write it like this. Whatever it returns, I put that right after the colon. Let me delete it. Let me write it one more time. So this is cube, which is equals to lambda, which is taking a number as an input, colon, which is modifying that number or returning the third power of that number or the cube of that number. That's it. This is, in case of Python, called as a lambda function. So this is a lambda function, and the lambda function is generally executed as a inline function, which means there is no separate stack frame created for it. I can come back here. I can simply call that same function back and say cube of 9, which is equals to, probably I can call that as a normal function, pass a parameter to that function as a normal function, and I can get the answer. So see, a cube of 9 is equals to something like 729. Whatever it is, I don't care about the actual value. I do care about the syntax. I do care about how the lambda function is created behind the scene. So this is the lambda. The lambda function is kind of a inline function in Python, and in this case also the same concept applies. The concept where we are creating a variable to a function. And of course, this is a function, and I can prove that point here as well. So I can say print, this is the cube, which is equals to a cube. And at the same time, I can come back here and say the type of cube, say the type of cube, which is equals to, again, the type of cube. So when you say run, probably you can understand this is a function lambda loaded at this particular location, and this, the type of this cube, is again a function. Now, probably you should not get confused looking at the syntax here, because earlier we were creating a function with the def keyword, and then we were using the function name. But behind the scene, I hope I mentioned that this is considered as a variable, and you can also say something like my square, which is equals to a square. So this is something which is called as a function alias, which we just have discussed a minute before. And because we can create a variable to existing function, I can create a variable to a special function, inline function called as lambda. So lambda here is a inline function, which we are getting a reference inside a variable called as a cube, and we are treating that cube as if we are calling a function. So we are calling that cube and we are passing a number to get the output of it. Are you getting something? Are you able to understand what am I writing here? This is inline function, and the inline function behind the scene uses the same concept. If you can understand this concept, you can easily understand this, you know. So this is a keyword lambda which creates inline function. Okay. It is suggesting me to use a def keyword before the cube. It's okay. This is suggestion. It's not hard and fast rule. This is a variable. You can treat it as variable, but because it is pointing to a function, it is saying just use this in this case. I don't care about that. I really don't care about this, because for me, this is a variable. Okay. This is just a suggestion. Not every suggestion given by PyCharm is valid. So don't trust that, Adesh. Just use what the documentation says. So this is how we can do the job. Cube, lambda, number star star 3. Now pay attention to another example. Let's say I want to add two numbers. See, this is a function I can write. Say this is an add. Now there are two parameters, P1 and P2. Someone was asking that question earlier. See the answer here. Maybe I can say return P1 plus P2. I can first call that function, get the addition result, and then I want to print it on console by saying something like a addition of, let's say, 30 and 40, which is equals to, I can simply call that function add and pass 30 and 40. I'm directly calling that function here. If you are a little bit confused, no big deal. I'm going to call it separately if you really want to. Say this is addition equals to add 30, 40, and then I can print that addition answer here. So probably 30 plus 40 answer is 70. It works. This is a simple function. There is no confusion. I hope so. Now you can call that function addition instead of using the add, or instead of using that original function add. I can also create a function alias. Maybe I can say my add is equals to add. This is again a function alias. Someone was asking that question, like how to create an alias to a function which is accepting a parameter. This is what I'm going to do here. Both add and myAdd pointing to the same function body, which is accepting 2 parameters, which means now I can say addition is equals to not add, but this time it is a myAdd. I can add, let's say 50 and 60. So I can say addition of 50 and 60, which is equals to 110. So let me just come back here and print that addition. And if I say run, probably you can see that both of them are giving me the addition of 2 numbers, which means both of them, myAdd and add, are pointing to the same memory block, the same function. Okay, so this is what it is doing the job. Now I know that it's a very simple inline function. Why am I wasting my stack frame? Why am I kind of wasting the memory? So not a big deal. I can convert that into a lambda. Now see, when you are converting this into lambda, you can literally take it down as it is, and then you can simply convert that by saying you can keep it as an add, a lambda, or a reference to a lambda. You can say this is the lambda, which is a keyword. You don't need any parenthesis for that. Remove the parenthesis and just remove the keyword return and just take it out on this line. So what are we doing here? We are simply creating a reference to a lambda being inline function. Sorry, inline function. That inline function accepting 2 parameters now, P1 and P2. And by default, whatever you say here will be returned as a return value. So ultimately, this can be represented. I mean, we can't do it there, but this can be represented by saying something like this is the list of parameters, and this is a kind of a return statement. Here, parenthesis cannot be used. Here, return keyword cannot be used. I mean, if you try to use that return keyword, you will get an error because by default, lambda will add that return statement for you. All you are saying here is you are getting 2 parameters and you are returning an addition of these 2. That's it. So maybe I can say a lambda add just for our confirmation that it is working. This is a lambda underscore add. This is the function. This is the lambda function we are creating. And again, I can call that function and then I can simply get the addition of other numbers. Let's say addition of 10 and 20, which is equals to 30, and I can get it by saying lambda add, let's say 10 and 20. So hopefully if I say run, yeah, I get the addition of these 2 numbers. Are you able to get what am I trying to show you here? These are, I mean, the lambdas we have created here, these are the inline functions, and those inline functions can be created or can be executed faster than our normal functions because these are simple functions. No stack frame will be created. It will be just executed in line on the same line and the result will be replaced there. So that is how the lambda function work behind the scene. Again, lambda is very useful when we go to the next concept. First, we are going to start with the collection, and in the collection, there is a topic called as map, filter, and reduce. These are the 3 basic fundamental functions with which we can process the huge amount of data. Think about it as a prerequisite for data science. So that is where the lambda will be useful. We'll use that practically later, but right now understand how to write the lambda, how to call the lambda, and what lambda does for you. Again, I hope if you open your PDF file, the notes PDF file, I already have mentioned where is it? Lambda. It's already mentioned there in your so-called notes. Let me just go back. Here it is. So this is the lambda. The lambda which you are using here is using a keyword called as lambda. There you can have as many parameters as you want, but at least 1 parameter is mandatory. You cannot create maybe a parameterless lambda. So you must accept at least 1 parameter that is mandatory, and it must have 1 and only 1 statement which is going to return the value. So basically, whenever you are saying lambda, there are 2 rules that you have to follow. One, it has to accept 1 parameter, at least 1 parameter, and it has to return the value which can be processing the input parameter or input parameters. This is what you mean by a lambda, and the lambda will be very useful later in this next couple of examples. Okay, so this is how it does the job. Parikshit, I already have shared this PDF on WhatsApp group yesterday. If you want, I can share it today one more time. After the session, I'll share that PDF file one more time. Okay. Okay, so this is how the lambda can be used. And believe me, the lambda is one of the important functions of Python. This is exactly the same case you are going to see later when we start with something called as a map, filter, and a reduce. Okay. Lambda also requests to a compiler like CPP. No, I mean, it does not actually compile, it executes the code in line. In a sense, whenever you are accepting the parameters, whatever the parameters are, this value will be returned to there. It's not going to even create a separate stack frame like it. Lambda is working as a macro. You can think about it as a macro, or you can think about it as an inline function. So both of them can be synonymous to the lambda in Python. Okay, if you are coming from C or C++, same macro, or you can say something like a inline function, you can compare both of them to lambda. So lambda works like it. Okay. Okay, do you want to see one more example of lambda, or are you okay? Have you understood the concept? Okay, if you have understood the concept, can someone of you tell me like how can I create a lambda to multiply two numbers? How do I create a lambda for multiplying two numbers? Anyone want to put that on chat? How do you create a lambda for multiplying two numbers? Sure, Pranita, I'm going to do that, but I want you to see whether you can at least try writing something. Yeah, I see many people already have tried that. Not a big deal. Let's see, Pranita, one more time. I'm trying to explain here. This is a lambda for multiplying two numbers. How do we do that? If you want to create a lambda, first decide what is the name that you want to assign here. I'm going to assign, let's say, multiply. For me, this is not a named function. I'm sorry, multiply. This is not a simple def function. This is the lambda function for me. So I'm going to say this is the lambda. When I say multiply two numbers, I'll have to get two numbers. So maybe I can say P1, P2, or you can say XY. It doesn't matter. I'm going to say XY in this case. What exactly you want to return from the lambda? You want to return the multiplication of these two, in a sense, say X star Y. So basically, what do you mean by this? Here is you are accepting two parameters. So this lambda accepts two values or two parameters, you can say, and returns multiplication of them. So this is how it does the job. So hopefully you can understand. It's going to be easier than writing a function. But again, when you're thinking about this, please put this diagram in your mind. Multiply is a memory block which is pointing to another memory block. There the lambda function is getting loaded. Okay, so probably I can say this is how it is going to do the job. Maybe I'll say F multiplication is equals to, I'm going to directly call this now. I'll say something like a multiply, and we'll pass, let's say 10 into 40, that's 400. Let's give it a try. And you see the answer is 400. So this is how we can create a multiply, which is going to multiply these two numbers. So again, there are a few restrictions when you are writing a lambda. Lambda must accept at least one parameter, and two, lambda has to return a value. This is again mandatory. Okay. Rather than only one return value, can we provide a body to lambda function? No, you cannot write a lambda with multiple statements in it. Lambda must be one single statement's body. So one statement body is kind of requirement. At least one parameter is kind of requirement, and the body must return a value is again another requirement of lambda. Lambda is pretty restrictive, but it is very useful in the context like map, filter, and reduce. So that is how you can do it. Okay, very good. I don't know who asked that question last time. Someone was asking that question: how can we create a function alias to another function which is accepting a parameter? So I hope the person must have got the answer. I forgot the name, but this was this was the question earlier, and this is the answer to that question. This is how we can do it. Okay, Tanya, you said where is it? Tanya, your question, you said there is no stack frame will be created, meaning I'll talk about that statement in the next session on Monday probably. Okay, I'm not talking about a stack today. We'll talk about it on the Monday, because that is another session where we have to see how the function is getting loaded in the memory, how the function's stack is managed behind the scene, and other things. Okay. Okay, it means the stack in case of lambda. Yes, repeat most of lambda. Yes, no problem. Siddharth, this is what I said earlier. When you talk about the lambda must accept at least one parameter. The lambda must have only one and only one statement in the body, and the body statement must return a value. So basically, I'm just making them bold so that you can understand what are the requirements to write a lambda. This is how you have to write a lambda. Very simple concept, but very, very useful concept. We'll see that later where you can use it. Okay. And yes, probably Rajendra, today you are going to get an assignment. I didn't share that assignment yesterday because there are a few questions in that first assignment which are there in the lambda. That's the reason we are covering those topics today. And today you are going to get not only one assignment, but also one quick quiz, which will have, let's say, at least 10 to 15 questions in it. Yeah, you will get a email later, or you will get a WhatsApp message later how to appear for that quiz. Okay. Anyways, that we will discuss on WhatsApp separately. First, let us come back here and finish the topic. So this is the lambda function we started, and this is how we can create the lambda. Please remember, lambda is very restrictive. These are the 3 rules that we have to follow when you are writing the lambda. The only good thing about the lambda is like it's very simple to write. It's very short, and this is very useful when you are doing some kind of processing using a map or using something like a reduce or something like a filter, which we are going to see later. Okay, so now there are a few more topics in function. This is something the function alias we talked about earlier. There are a few more topics in the function, like variable length argument function. There is something called as a nested function, function within a function. There is something called as the scope, and all of these things. We are going to discuss them one by one, step by step. Okay, we'll see them in a later session. Now today I want to start with one more simplest topic. I mean simplest but most powerful topic in Python. Again, please remember there are few function topics we are going to discuss as and when we go to that topic. Okay. Yes, probably I'm going to start with the collection here. Who's that? Soham. This is exactly similar to the function. There is no separate diagram required for lambda because lambda is exactly like, you can think of it as an inline function. Wherever you are writing a lambda, that value will get replaced with the body. That's how it does. There is no separate diagram required for it. Okay. What about 2 variables with the same name? Probably you can guess that because last time also the same thing happened. I hope you might have seen that in the diagram as well. Didn't you see it here? When you are having the same variable like num equals to 100 and num equals to 200, for you it is like 2 different variables with the same name, but for Python it is the same variable. One is the initialization and the second one is assignment. Okay, so probably Rohit, this is how it handles, the condition gets handled in the Python. Okay. Okay, so can we use a lambda if the loop is present in the function? No, you can't. There is a different story when you talk about the loop, and that's what we want to see in the topic we have started today, that is collection. So let me come back here, create a page 4. Guys, pay attention to this. This is the simplest topic, but it's the most important topic in the Python, at least for those who want to go or who want to pursue their career in data science. So see what you have to do in case of data science and what is the base or what is the foundation for that in this topic. I'm talking about something called as the collection. What is the collection? For you, if you are coming from other languages like Java, like C or C++, this is nothing but an array or collection. So collection or array in other languages, in case of Python, is called as a collection. So collection is nothing but a collection of different values. And that's how you can define that collection in case of Python. Now, when you talk about the Python's collection, Python's array, there are 4 ways you can create collection in Python. So probably if you just scroll down somewhere, where are you? Somewhere, okay, built in, that's here it is. So somewhere in the collection, there are 4 ways you can do it. 1 is something called as a list. 2 is something called as a tuple. That's the first one. The second one is called as a tuple. Let me write it here better. List. The second one is called as a tuple. The third one is called as a what? The unique set. Sorry, set. And the fourth one is called as a dictionary. That is a collection of unique values. That's a set. And finally, there is something called as a dictionary. Now we are going to start with the simplest one and the most useful one. I'm talking about something called as a list. So let us see what list is, how you can create one, and how you can deal with it. Believe me, this is very simple. Let's see. This is a kind of a function I'm writing here. Not necessary that you have to write a function, but it will be easy for me to demonstrate different versions of sets, that different versions of lists. That's the reason I'm creating different functions. This is the function one where I want to create my numbers list. When I say numbers, numbers is where I want to put different numbers into it. So how do I create a list? Now, please remember, when you are in Python, the symbol or maybe the punctuation mark really matters a lot. When you are in Python, the list can be created by using square brackets. The tuple, I've not talked about the tuple yet, but later, once we are done with the list, we are going to talk about the tuple. The tuple will be created by using parenthesis. The set will be created by using a curly bracket, and dictionary will also be using curly brackets like this. So what are you using to create the collection? That matters a lot. If you use a square bracket, it will treat it as a list. I'll show you an example here. See, I want to put different numbers into a collection. So probably I can say a square bracket and I can say 10, 20, 30, 40, and 50. So what are we doing here? We are simply saying this is an array of numbers. Now, when I say array of numbers, the numbers are nothing but the integer values for me. Let me come back here and put that print number statement so that we can see the numbers directly on the console. And at the same time, I want to print the type of number as well. So type of numbers, which will prove the fact that we are using a list. So let's say this is function one, and let me give a call to that function, and you see that this is a list 10, 20, 30, 40, 50, and this is the type of numbers, which is again a list. Please remember, as I said earlier, if I just put a kind of parenthesis, the data type will change. So make it, use a square bracket to create a list. Because if you use parenthesis, it will create it as a tuple. We'll explore this later once we are done with test. And if you use something like a curly bracket, by default, it will give you something called as a set. So here, this bracket matters a lot. That's the reason why I'm again saying the same thing. Use square bracket to create a list. So that is how it does the job. This is a very simple list of numbers. I'm going to create a separate function to create a list of strings. So maybe this is a separate function. Here I'm going to say array of strings. Okay, so how do we do that? To do this, I'm going to say countries, for example, where I can put different countries. Let's say India, USA, UK, China is gone. China is something we are having a fight with in a couple of months or a year or so. So countries, and this is a list of strings, as simple as that. You know, I'm just going to put that countries here. Again, put the type of country again, like last time, the type of countries, which is equals to, again, the type of countries. Let's call that function and verify. So when I say run, you see that earlier we were getting the list of numbers or the collection of numbers. Here I'm getting the collection of strings. Both of them are the lists. Only one difference is this is the list of numbers and this one is the list of strings. Rest is exactly same. Exactly. So this is how the list is created. Very, very, very simple. There is nothing difficult to understand here. Really, there is nothing difficult to understand this in here. Okay, now the point here is when we are talking about the numbers or countries, I mean, I'm going to play with the numbers right now, but all this functionality will be exactly similar in case of a list of strings as well, or list of booleans as well, or a list of objects as well, or the list of floats as well. So important thing is the list. What are you putting inside the list is not that matters. Okay, so now we are having a list of numbers. I want to play with it and I want to perform few operations. The very first operation that I want to perform is how many values you are having here. So probably I can say the number of values in numbers. Numbers is my collection. I can say, the len of numbers. That's the collection we are using here. Naturally, because we are having 5 values, the answer is equals to 5. Number of values we are having in that numbers collection is 5. So dynamically, it is going to count the number of values and it will tell me that there are 5 values. Now, why it is important to know the number of values here because if I want to get all the values one by one in a for loop, it really requires to, I mean, it's really important for me to see how many values are there. So accordingly, I will start my for loop, and accordingly, I will end my for loop. Unfortunately, you cannot do that traditional for loop here as simple as your C or C++ syntax. It's a little bit different. In Python, whenever you want to write a for loop, so this is a kind of a for loop I'm going to write. So this is a for loop, and this for loop is going to run, or it's going to iterate over the collection, and it will give you a value at a time. So how do you write this? To write this, the syntax is a little bit different. So you are going to say for. In other languages, you start with parentheses, you start with integer index equals to this, blah, 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 blah. Here, the good thing about Python is like the parentheses are not required. You can simply skip the parentheses. And you can say that for every number, basically you are having different numbers inside the numbers. So you can say every position is a kind of a number for me. So I can create a temporary variable called as a number. And I'll say, for number in numbers. What do you mean by this? Or how will you read this? For every number in numbers, every number in a sense, first it will go to the 0th position, it will copy this 10 value into number and will give it to you. Then it will go to the second position, it will go to the 20, it will get the 20 value, put that in number, and it will give you. Again, it does that till the end of the list, and then it comes out of the for loop. So for every number in numbers, what do you want to do? Nothing. I just want to print it. So I'll say the number is equals to number. That's it. So this is how I'm going to do the job. So for loop is a little bit different than your traditional for loop if you are coming from C or C++. But those who are coming from Java or C#, for them, it's very simple to understand because this is generally called as a for each loop. So whenever you are in Python, by default, you can write only for each loop. Of course, this is not a for each in Python. This is a for in Python, but for in is exactly similar to for each. So this is how we are going to get every number or every value inside that array or inside that collection. You see, I'm getting the number equals to 10, number equals to 20, number equals to 30, 40, and 50. It automatically starts iterating your collection from position 0. It automatically ends it to the end of the list. So that is how you can do the job. So probably I can get all the values from that numbered collection. I can also do the same thing for the string collection. So again, I can see how many values are there. I can say number of countries is equals to the same one, len of countries. And I can run a for loop by saying for country in countries. And then you can say print the country, the country is equals to the country. That's it. Again, this is a variable we are temporarily creating just to access the value at every single position. You can put it anything. You can say a value as well. It really doesn't matter. But if you're using value, make sure that you are using a value here as well. So again, it's exactly the same thing. Okay. I don't want to create it as a value. It makes sense because all of these are the country names. So probably I can say country in countries, and yeah, it makes sense. And here I'm getting, there are 4 values, there are 4 countries in my collection, and those 4 countries are India, USA, UK, and Japan. That's it. This is the way exactly what we have done in numbers collection. There is no change. That's what I said. You can deal with only one type of collection, and other types will be exactly similar. There is no change. Okay. Fayaz, does compiler by default adds a null character to the end of the list? No, and not it's not like that. It just keeps on adding the different values. Wait, in the next session, I'll give you the memory management, or I'll give you the memory address structure, what happens behind the scene when it creates a list. Okay, but it does not add a end of the list or null character there, for sure. Chandrakant, if we have to access a random value within the list, then how can we access it? Naturally, when you are doing something like this, this is called as a for each loop. And when you say the for each loop, it becomes a little bit difficult for you to understand like how it is starting from 0 or how it is going to the last value. If you want to do it yourself, not a big deal. You can also do it yourself by saying, by saying something like, say value at 0th position, which is equals to, what is it? probably this is the numbers. So I can say numbers of 0. The value at the first position, second position, third, fourth, and fifth. So I can say the first, I can say the second, the third, and then the fourth. So basically this is how I can get the values on different 1, 2, 3, and 4. I can get the values on different positions, something like the subscript method. This is the way we are going to do it in other languages like C. So this is using subscript. Okay, this is the subscript method. So probably when I say run, you will still see the exact same output. 0th position, we are having 10. First position, we are having 20. Second position, we are having 30, so on and so forth. So how we want to get the values at a particular index? This is the answer to your question. So probably Chandrakant, this is the answer to your question. This is the for in loop. For in loop starts from 0th position and it goes to the last location of it. Now, sometimes it matters a lot that you want to start in between or you want to stop in between, where you don't want to go from 0th position and you want to you don't want to go to the last position all the time. You want to stop in between. How do I do that? See this. Now, when you are in Python, it's not that easy to write a traditional for loop. Now, when I say traditional for loop is exactly similar to C. So when you say traditional means this is how generally it looks like. For integer index equals to 0, index is less than something, let's say in this case it's a 5, and then index plus plus, and this is where you write the code. This is generally called as a traditional for loop. Now, if I want to write something similar where I want to control the index starting, index initialization, index incrementing, and index termination, then there is a little bit different syntax. It's a little bit different. So let's see how it can be done. See, the very first thing is I have 4 values in it. I have 5 values in it. 1, 2, 3, 4, and 5. This here will start at the 0th position. This here will have the first position and so on and so forth to the 4th position. So what I need to do here is like I need to create one more list or one more array, whatever you say here, as index values, which is equals to 0, 1, 2, 3, and 4. So these are my index positions. Instead of saying index values, I can call them as index positions. And then I can start running the for loop by saying for maybe index in index positions. And then you can say the printf again, a value at this index, which is equals to again the numbers collection of index. So writing traditional for loop is a little bit different than the C or than the other languages. If you really want to get your own indexing mechanism, then you have to do it with this way. Again, the answer will remain same. There is no change in the answer. You see, the value at 0 is equals to 10, value at the first is 20, and so on and so forth. So the answer is not going to change, but the way we are writing the for loop is a little bit different. So here we have to create a separate array for it. And then again, we have to write the same syntax, for in syntax, in order to get the index positions. And based on those index positions, we can retrieve the value. So this is how we can do it. Now, creating this index positions, in this case is simple because I'm having only 5 numbers, so I can say 0 to 5. But what if you are having thousands number? Are you going to say that 0, 1, 2, 3, 4 up to 999? Of course not. There should be a shortcut, isn't it? Now the shortcut here, first let me show you the shortcut and then we'll write the same code one more time. So the shortcut here is something like you can go for a index positions. See here, index positions equals to, you can call a function called as a range. Range is again a defined built-in or predefined function which is given by Python. So inside this range, you can pass 3 parameters. The start parameter, the stop parameter, and the step parameter. Now forget about the start, stop, and step. First, I want to write only one, which will have only one parameter for now. I can say, give me the range of first 5 numbers. What do you mean by that? I'll show you that in a second. I want to get the range of 5 values, and I want to convert that range to a list. So first, don't forget to call the list and pass the range here, because range will return you a reference, and that reference need to be passed to the list in order to get the range of or the list of range 5. So here I'm getting the list of range 5 values. Range 5 values means exactly what you see here. Let me just print it and you will see it's exactly similar to what I've done earlier. So probably I'm going to say this is the index positions, which is equals to, again, index positions. See, what does it print? It prints exactly the same thing. Index positions 0, 1, 2, 3, 4. So it starts from 0, it goes to this number less than 1. The number is 5, so less than 1, that is 4. If I say 10, so probably if I just say run, it will give you the value starting from 0 to 9. So probably, as I said earlier, if you're having 1000 values, then you can say 1000 and say run, and probably it will give you 0 to 999. So if you just scroll up to the last point, you see that it is 999 here. So this is how you can get the range of the numbers. Now, why did I show you that? I showed you that because if you don't want to create that index positions by hand, then you can say list of range of how many values do you have inside the inside that collection. So I hope last time I showed you, we are having len of numbers value. So you can pass that len of numbers value, and probably it will do this job dynamically. Means tomorrow, if I add a 6th value, let's say this is 60, you see, automatically it is going to increment this to 5, and this will tell you that you are having 6 values within it. Tomorrow, if you add one more value, one more value, one more value, one more value, see, automatically it starts from 0 to 9 because you are having 10 values within it. Guys, are you getting this? I'm telling you like how to create that index positions dynamically. You don't have to do that manually or explicitly or using that hard-coded values like 0 to 4. You can just do it as quickly as possible by saying list of range of len of numbers. I know it's a little bit complicated to read, but this is how it is. You are getting the len of numbers, which is the count. You are passing it to the range, which will give you all the values starting from 0 to something, and then you are converting that to a list. Once you have that index position, the next code is exactly what we have written earlier. Just write the same code, and if you say run, you see you are getting the values here. So again, in Python, if you are controlling your own index, this is generally known as a traditional for loop. You know, so traditional for loop and even the for each loop, both of them are going to use the for in loop. But the only difference here is in for in loop, we are not controlling the index values. Here we are controlling the index value. I mean, tomorrow, if you want to start with, let's say 2 to 5, then you decide. For example, I don't want to see all the values. I want to see only those values starting from, let's say 2 to 5. Simple, just say 2, 3, 4, and 5. That's it. So you are going to get only those values. You see, value at 2 is 30, value at 3 is 40, value at 4 is 50, value at 5 is 60. Exactly what I can control here, which is not possible when you are using for loop alone. So if you do it something like this, it will always start from 0. It will always reach towards the end of it. But when you want to control that index on your own, you can write a traditional for loop. And when you write a traditional for loop, it's mandatory for you to create your own index positions array or index positions list like this. So this is the way you can create an array, or you can create a list. A list is similar to array, by the way. So this is a list, and that list can be used for storing the number values, storing the string values, storing the string values, storing the float values, bool values, objects, and whatnot. You decide what you want to put there, and you can create a simple collection called as a list there. Now, list is going to be very important because most of the times, generally you use the list rather than using a tuple and the other thing. So list is going to be important. This is where we started using list. Now there are many other operations like how to add a value, how to remove a value, how to deal with the list with different functionality is what we are going to explore later. Okay. Explain the list part 30, 40, 50, 60. Okay. When you're talking about this, who's that? Fayaz, when you're talking about this, I created a separate position. So it's like 2, 3, 4, 5. So basically what we are doing here is we are trying to get the values only from those positions. It's like instead of doing this, it's like you are trying to say, hey, I just want to get the values on these particular positions by literally saying print value at 2 is equals to something like the numbers of 2. And if I want to do it for 3, 4, 5, I can say this is a 3, for example, 4 and a 5, sorry, and the 5. And this is how we can do it without having a for loop. So if you really want to use a for loop, then this is the one with which you can solve the problem. And if you don't want to use the for loop, this is how you can do it. Okay. So Fayaz, instead of writing code like this, which is kind of repetitive code, we created a list of values like 2, 3, 4, 5, and then we iterated that list by using a for in loop, and then we got the values on those particular index positions. Utpal, can we give a range of second to fifth position? Of course, yes. If you don't want to do this, then you have another option as well. Let me show you this option here. Don't want to do it, but I still want to do that here. I want to get the values from 2 to 5. I'm sorry, 2 to 5 like this. I'm getting the values, but here I created them by hand. In a sense, I have created, or I have started with 2 to 5. Instead of doing this, we have that range function. So I can call that range function. But if you say only 5, it is going to start from 0 to 4. I hope you already have seen it. No, not that. I want to start from 2 and I want to reach to 5. Just remember, range will never include the upper bound. So if you want to go till 5, you have to add 1 to it. So say 2 to 6, and this is going to give you exact same values. Do you see that? 2, 3, 4, 5. So this here will be exactly writing like 2, 3, 4, 5. So probably Utpal, this is the way we can do it. You can pass the start index and you can pass the stop index. Start means where you want to start, stop means where you want to stop. Please remember, let me mention it one more time. Stop in the range will not include, we'll put that not in capital, will not include the upper bound. When I say upper bound, 6 here is the upper bound. So it will go from 2 to 5. That's how it is going to do the job in case of line number 42. Okay. Rachid, your question, can we print the value in a decreasing order? Yes, we are. Not right now. There are a few topics. There are a few more topics we have to explore. Python is very flexible when you talk about the collection, and there are many things we have to explore here. So this is just the starting point. There are many different things coming up. So Rachid, you will see that later. Okay. Vishal, index position can be given dynamically. Yes, we already have done that, isn't it? You see here, list of range of, where is it? List of range of lane of numbers. This is a dynamic position. Okay. And if you don't want to go for it, use this one. I mean, if you're in Python, you generally will prefer for in loop like this. But if you really want to go from one specific position to another specific position, this is the way you can do it. Not often that you are going to use this one, but frequently you will use, or you will prefer using something like a for in loop in this particular way. Okay. I think today's topic was a little bit difficult to understand. That's how I am kind of guessing it here. So I think you will need some more time to pay attention to, and you will need some more time to practice it. So don't forget to practice it. You are going to have 2 days in your hand. So please practice it again. Understand this concept again, because on Monday we are going to talk about some more advanced concepts, and those advanced concepts are dependent on this one. We started talking about the list here. This is not the end of it. If you look at your notes, I think you will find that there are many things we have to pass here, many things we have to see here, like extend, clear, copy, append, reverse, and so on and so forth. There are many different things. Yeah, there are many different things here that we have to see. Okay. Okay, so there are many different things. I hope you will find that in the notes as well. But anyways, on Monday, we will talk about the advanced concepts. Okay. Yes, it's a weekend and you'll have to, again, practice it. Unless you practice it, it will be very difficult for you to do that. Okay. Ashwin and Utpal, I don't recommend any book, because there is not a single good book on Python. If you want to read something on Python, then the best option for you is to go for python.org. I think I mentioned that yesterday. The documentation is more than sufficient for you. There's not a single good book on Python. What the hell? Python. So there's not a single book, a single good book that will cover every single thing for you. So it's always better to refer the documentation. And believe me, documentation here is very, very, very nice. And when I say very nice, it is having every single thing that you need. Precisely, if you go for something like a documentation here, you see, for example, okay, not in this case, if you want to search for something, for example, I want to search for list in this case. So probably I can say that list. There are many different topics here. Probably I just go for a simple, there are some advanced topics, not this one, not this one. Writing a setup script, not even this one. Built-in types, okay. So, or maybe I can go for the other one as well. There is the one, built-in topics or list objects. So if you go for list, you can see every single functionality in the list: insert, update, or append, or something like extend, and there are every single examples they have given here. It is very nice documentation. So probably if you are searching for something, you can use a documentation instead of a book. That is a better option. Okay. Anyways, yes, assignment. Yes, I'm going to share that assignment today. I already have prepared one. So probably this assignment will be shared by maybe by afternoon, and probably you are having 2 days. So you can definitely go for it. Okay. Yes, secret result tomorrow. I don't know. Probably Ajinkya, I have not seen it. So I hope so. It is tomorrow, but I'm not sure. I can't answer your question, Ajinkya. Anyways, thank you very much for attending today's session, guys. I hope you are having a good weekend, and probably when you get a time, please go for the notes and go for the programs we have written so far. I'm going to share the code along with the PDF on your WhatsApp on your GitHub URL as well. Okay. Again, thank you very much. Have a very great day ahead. Have a good weekend, and I'll see you exactly on 8 o'clock Monday morning. Bye bye.